Now this illustration deals with conductors in parallel, in accordance with NEC 310.10G. Now notice to the very right of the illustration at the very top, we have a title head. This parallel installation compares and complies with 310.10G. Now phase A is 4-aught THWN copper conductors. Now notice in phase A, the length is 70 foot in the illustration to the left. Phase B is 4-aught THW copper, and notice the length is 68 foot long. Phase C is 4-aught XHHW copper, and notice the conductors are 68 foot long. The neutral is 2-aught THWN aluminum, and notice 67 foot long. Now what this illustration is trying to get over to the test taker is that only phase A conductors have to be the same length. Only phase B conductors have to be the same length, but A could have a different length than phase B as well as C and the neutral. Now that's what we're trying to point out here, that although this is a sloppy looking installation using these different insulations, copper and aluminum, but notice it's a legal installation according to 310.10G. Now the phase conductors along with the neutral, equipment ground, or whatever you have in the circuit, notice that the NEC loop now states in 310.10G1 through G6 gives you these listings and these rules. And notice that 300.5I says that if you have conductors routed and conduit in the ground, they would have to be complying with 310.10G as you see in the illustration. 300.20 is where you exit and enter into the equipment as you see in the illustration, and they have to be grouped together. 300.5I exception 2 says if everything routed conductor-wise is in non-metallic conduit coming into a non-metallic bottom, or a bottom that's totally open in a switchgear, say, that these conductors could be routed all A, all B, all C. The neutrals could be in separate and non-metallic conduits. In other words, what this is saying, that they would not have to be routed together in the same conduit as you see in the illustration. Now we just use one conduit in this illustration for simplicity's sake, so that you can see it without it being so busy that you might get a little confused or it'd be hard to draw. Now, review that NEC loop very careful. We put it there for a reason, because it's so important to electricians to know, because you could get either one of those sections as a question. As you will see in the very back of this chapter 2, we have questions and problems with answers and steps to these answers and to problems, and the sections are validated for you so you can look it up. Now reviewing the note 1, it states the length of the conductors on phase A have no relationship to the length of the conductors on phase B, C, and neutral. Keep that in mind now, because that is a question that can certainly come up. Note 2, also see 250.4A5 and 250.102 C as in car 1 to size the grounded neutral conductor to carry the fault current. We know we have to have a grounded neutral conductor large enough to carry fault current, but we also know that it has to be large enough to carry the neutral load. So whichever calculation provides the largest conductor is what you would use. and calculate. Now, more information can be found in our chapter dealing with grounding and bonding in Stallcup's Electrical Design Book, Volume 2. But if upcoming books that we're writing, we will find that we'll have Stallcup's Grounding and Bonding Made Easy series, just like we're trying to write these books so that we get to the point in these books real quick so that you don't have to read some stuff and things that'd be nice to know, but you wouldn't have to know to take an examination or design or make an installation and so forth. Now, step 3 for sizing the neutral conductor, we have to follow the rules of 220.61a through C, now as well as 310.15E3 to see if the neutral's current carrying, which we reviewed in one of the previous illustrations. So keep that in mind, that the neutral has to carry the unbalanced load on any phase A, B, or C, or L1, L2, or L3. But the neutral conductor also has to be large enough to serve and carry all the neutral current load, as well as return fault current if that condition occurred, which we naturally don't want that to happen. Now, note 4, we're sizing the equipment grounding conductor in accordance with our section 220.122B and F. And notice the neutral conductor has to be 1 or larger to be connected in parallel due to the resistance of the conductors. But the equipment grounding conductor does not have to be 1 or larger. So if one is provided for any reason. So keep that in mind, like on a feeder and so forth. Now, the neutral bar terminals is 408.20 for terminating. Now, this illustration, 2-23, is illustrating the requirements for conductors when they are connected in parallel in accordance with 310.10G, and for the neutral 220.61, and for the equipment grounding conductor 250.122B and F. So review these sections very carefully for parallel hookups of conductors, and that's what this figure 2-23 is illustrating.